So we are going to look at how to find solutions that are not possible to find on the unit circle. And to give you an idea of where our shortcuts come from, we are going to draw pictures today. We are not going to draw pictures for every problem we ever do. Just for today, so we can see where the shortcuts come from. And then after today, you can use the shortcuts to just do the problem. Okay? So the first one, we're going to say that sine theta is 1/3. Sine theta is 1/3. And I'm going to be solving for theta. Now, when we were working on the worksheet, can you guys pass them some paper? From up there. Yeah. You can open it. When we're solving for theta, we always have two answers on the unit circle. Do you guys notice that? Yeah. It's always two different spots, okay? So to figure out what two quadrants our answer should be in, I'm just going to remember all students talk constantly, right? So sine is positive 1/3. So what quadrants are my two answers going to come from? Quadrant 1 and 2. I'm going to get an answer for both of those. So I'm going to go ahead and draw a picture in quadrant 1 and 2. There's my triangle. Here's the angle that I'm talking about. I have my opposite side and my hypotenuse. I have the opposite side and the hypotenuse. Make sense so far? Okay. All right, so now if I was to solve this equation, how do I get rid of sine? Inverse. I do inverse. Okay, so I'm going to say theta equals sine inverse of 1/3. And we have been working in radians, so before we use the sine button, we have to make sure that our calculator is in radian mode. Okay. And I'm going to press sine inverse of 1/3. Okay. All right, 0.339. 39 is followed by an 8, so what should 39 do? Go up to 40. So I'm going to say that theta is approximately 0.340. Okay? And I'm going to show you what your calculator means by that decimal. Okay? Your calculator means that this right here is 0.340. Okay? So it gave you one answer, 0.340. That's good. We like that answer. That is one of our final answers. The other answer that the calculator gave you is that this angle is also 0.340. Do we ever measure angles like that? No, we don't, right? Instead, we would measure the angle from here. That's how we should measure that angle, right? Okay, so to get the purple angle, I'm going to say that the purple angle is the entire half of a circle. That straight line represents pi radians. So I'm going to say the purple is all of pi minus the red. Does that make sense? All of pi minus the red. So the little shortcut that I'm going to write, this is how I get my second answer. My second answer comes from doing pi minus the theta that I got for my first answer. That's my shortcut. Okay? And that's the purple. The purple is the entire thing minus the red. Okay? So what I'm going to do on my calculator is that 0.340 needs to be stored. So I'm going to store this as x on my calculator. And then my second theta is going to be pi minus x. And so my second theta is 2.802. There's my two answers. All right? So now, from now on, you don't have to draw the picture. You just know. I get the first answer. That's my theta. My second answer is going to be pi minus that answer. That's my second one. And then I have my two answers. I'm done. Okay? Yeah.
talk about the
Yeah. Okay. All right, next we want to see what's different if our sine is a negative fraction. So I'm going to say sine theta is negative 1/5. So if sine is negative, and I'm thinking about all students talk constantly, we are no longer going to draw our picture in quadrant 1 and 2. Where are we going to draw our picture? 3 and 4. So I'm going to make a big picture. My triangle is in 3 and 4. Opposite over hypotenuse, opposite over hypotenuse. So there's my new picture. And if this is my equation, how do I solve for theta? Sine inverse. So I'm going to say theta equals sine inverse of negative 1/5. Okay. So sine inverse negative 1/5 is negative 0.201, right? Okay. So that means it's a little decimal and it's negative. That means that our calculator measured this angle backwards. You see that? It measured the angle backwards. If they said in the instructions they wanted to have the answer to be between 0 and 2 pi, would this answer be acceptable? No. It wouldn't. So I'm going to go ahead and store this decimal in my calculator. I'm going to store it as x. All right. If I wanted to find an angle that was coterminal to this one, but was positive, I would plus 2 pi. So I'm going to take that decimal, I'm going to add 2 pi. So this answer is in the same spot. They just didn't measure it the negative way. They went around the positive direction. Okay? So I'm going to go ahead and write that down. That's my first angle.
I'm confused on why we added 2 pi.
We added 2 pi because 2 pi is a full circle. It brings us right back here. So we haven't found our second answer yet. We have only found our first answer. Okay?
So there's no point having negative 0.2.
We're going to use it in a second. Yeah. So I'm going to write down on here, I stored that as x. I'm going to use it in a second. Okay? So this is considered to be my first answer because I want to be good at finding answers that are between 0 and 2 pi. Okay? Now, the second way that this picture measured that angle is they said that this right over here is negative 0.201. Have we ever measured angles over here? No, we don't want to measure it like that. What we want instead is we want to measure it from here all the way around to right there. So we want a full pi. You see that? We want a full pi plus a 0.201. Okay? What if I do pi minus x? What's going to happen? It's going to add it because it's a negative. So if I do pi minus theta, I'm still doing that same formula. Since my theta was a little negative number, it's going to do minus minus makes a plus. Okay? So my shortcut to find my second answer, I'm going to go ahead and write this on my paper, is still pi minus theta. It's still pi minus the first thing that I solved for. Okay? So I'm going to go ahead and type that in my calculator. I've got pi minus what I stored as x. It's going to add it because you're subtracting a negative. And it's going to do it. It's going to do it, and it's supposed to do that. And if you can see, our number makes sense. We had 3.343. This line right here is 3.14. That's pi. And so we went a little bit past pi. So that's valid. That makes sense. Okay. So our second answer here is 3.343. And now we know anytime we're doing a sine problem with the calculator gives us our first answer. And then if we do pi minus our first answer, that will give us our second answer. Okay? these ones, these ones are just remembering the different, there's one shortcut for sine, one shortcut for cos, and one shortcut for tan. So it's the fact that there's 3 shortcuts that make it hard. But really, this is just memorizing the shortcuts. Yeah.
So, alright, just so I can write it down.
Mm-hmm.
We got 6.02. That was theta plus 2 pi.
Yeah, and that was us. We had a negative answer, and we wanted to find the answer that was coterminal.
Like we do when we're finding
Yep, yep. So we were just finding a coterminal angle. And then the second one was using that shortcut. Yep. Okay. All right, we're going to look at cos next. So we're going to say cos theta equals 2/3. Cos theta equals 2/3. And we have all students talk constantly. And so what quadrants should I draw my picture in?
1 and 4.
1 and 4. So where all are positive and then where cos is positive. So all students talk constantly tells me quadrant 1 and quadrant 4. So on this one we have adjacent is 2. That's a 2 right there. Hypotenuse is 3. The adjacent side is 2. The hypotenuse is 3. Okay. So I'm going to say theta is cos inverse of 2/3. Yep. Okay, so theta is 0.841. So that's this one right here, 0.841. Is that a valid answer? That was good. That was good because it went up. That's normal. Okay. Now the other one says that they measured down 0.841. Do we want to measure the angle like that? Nope. We want to start at the beginning and we want to go all the way around, but we don't want that part. So I almost want a full circle, but I don't want the red to count. 2 pi minus the angle we just got. So the shortcut for cos is going to be 2 pi minus the first angle we get. This is our second answer. 2 pi minus the angle we got. So I'm going to store this. And then I'm going to do 2 pi minus that. Okay? All right, so we also want to do an example where we have a negative cos. So here I'm going to say cos theta equals negative 5/8. Sorry, I didn't box that. Okay, so cos theta equals negative 5/8. And again, we're going to think all students talk constantly. And so the 2 quadrants where cos is negative would be quadrant 2 and 3. So we have adjacent and hypotenuse, adjacent and hypotenuse. So I'm going to go ahead and work on solving this. I have theta is cos inverse of negative 5/8. And so cos inverse of negative 5/8 gives me 2.246. So what you can actually see is that the decimal that I just got, it's not a small decimal. It's not between 0 and 1.57. It actually gave us this whole part right here instead of giving us that little part there. So my first solution is going to be 2.246. And then that means that the second solution that it gave me was this part down here. But that's not the part that I actually wanted. The part that I actually wanted was from here all the way around to right there. So again, I want to use that shortcut where I have the whole circle minus the red part. So minus the angle that I solved for. So I'm going to take this, I'm going to store that as x, and I'm going to do 2 pi minus x to get my second solution. So my second solution is going to be 4.037. All right, and then I also want to do tangent examples. So 2 more to get our shortcuts all in. So first we're going to do tan theta equals 3. So if I think about all students talk constantly, tangent is positive in the first quadrant and the third quadrant. So here's the first quadrant, there's the third quadrant. We have opposite over adjacent, so opposite over adjacent, opposite over adjacent. So I can say that theta is going to be tan inverse of 3. So tan inverse of 3, and theta gives me 1.249. Okay, so the way that your calculator measured it is it measured this angle right here. So that's a good angle. We can use that as an answer. It also measured this one right here. So for us to get our other answer, we want to measure it like this, which means that we want to have pi plus the red. So I'm going to store this as x, and then to get, sorry, there you can see, I'm going to store that as x, and then to get my second answer, I'm going to do pi plus x. So I'm just going to add a pi to that. Okay, so my second answer is going to be pi plus x. Okay, and then one last example. This time I'm going to do tan theta equals -2. So now we're saying all students talk constantly, and we're going to draw the quadrants where tan is negative, which is quadrant 2 and quadrant 4. So we have opposite over adjacent, opposite over adjacent. So theta is going to be tan inverse of -2. And it gave us the negative version of the angle. So it gave us this angle right here. So if I want the angle that is coterminal with that, I can go ahead and actually I'm going to store this real quick so you guys can see something in a second. So I'm going to store that as x. Okay, so to find an angle that is coterminal with that, I'm going to add a whole circle. I'm going to add 2 pi. All right, so that is 5.176. So theta is 5.176. And then this would give us the other angle. That's the negative 1.107. And what we actually want is this part right here. And so even though this says pi plus x and that seems wrong, it's actually going to work, because if you do pi plus x, your x was a negative decimal. So if you do the entire half, so from here all the way over to here, and you add to it a negative decimal, then it will back it up and it will put the answer exactly where we want it. So I'm going to say pi plus x. 2.034. Okay. Now, before we put our notes away, I just want to remind you guys, as I went through here on these examples, I only wrote the answers that were in between 0 and 2 pi, but we do know that we have the repetitions of answers. If I had said in the instructions, I want you to find every single possible answer, then you would have had to add things on the end of this. So, for instance, with this problem right here, remember my x was negative 1.107. If I added pi, because it's a tan graph and my answers repeat every pi, then I get to the 2.03. If I add another pi, I get to the 5.176. And I could keep adding pi's, right? And then I could keep getting more answers. So for this one, if I wanted to say all possible answers, then I could have said this plus pi k, this plus pi k, or this plus pi k. It doesn't matter which one I use, because all of them would give the same redundant answers, okay? Now this one is also tangent, so to do all of them, I would say this one plus pi k or this one plus pi k. Again, it doesn't matter, right? If I go back to the other pages and I want to say all solutions for these, then I would say 0.340 plus 2 pi k, 2.802 plus 2 pi k. I don't have the option of using one thing to represent all of them. For sine, I could have used this one plus 2 pi k or this one plus 2 pi k, because these were coterminal. They were in the same spot. It doesn't matter which one you choose if you are writing all solutions, because all solutions do not specify you have to have your starting solution be from 0 to 2 pi. So again here, my all solutions answer would be 0.841 plus 2 pi k, 5.442 plus 2 pi k. And then my all solutions for this one, 2.246 plus 2 pi k, 4.037 plus 2 pi k.